All right. So here we've got factoring. We're going to use the difference of cubes formula. All right. So the reason it's the difference of the reason it's the difference of cubes formula is because it is a subtraction here. It's a subtraction here. That's the reason it's a difference of cubes formula. So that tells you which of which of these two formulas to use. Okay, dokie. First thing I want to do is express both of these as something to the third power. So here, it's already done for me. That's just x to the third. The 27 is the same as 3 to the third power. All right. We're wanting to do that so that way it kind of matches our original getup, our original setup. All right, we have to have something to the third power minus something to the third power in order to apply the difference of cubes formula. All right, so the way it's going to start is we're going to have a minus b. All right, so here that's going to be x minus 3. X minus 3. Not too bad. And then the next term is an a squared. So that's going to be this term squared, x times x squared. And keep your signs in mind here. So the first one was a minus, and the next two are going to be pluses here. So plus, and then it's going to be a times b, which is 3 times x, plus b squared. So b to the second power, 3 to the second power. You get a 9 right there. Okay? And that is our factored form for that one. There's no reason to try and check to see whether this quadratic right here is going to factor any further. Like, oh, maybe it factors into two binomials. It's not going to. I mean, there might be some case out there where someone's like specially designed a polynomial to do that. But in general, this thing right here will not be factoring any further. Okay? All right, one more on this. Again, this is going to be difference of cubes formula. So we can't start doing it quite yet because 2 and 250, these are not perfect cubes, so we can't jump right into it. First thing we need to do is divide by 2, or factor out the 2 technically. So I'm going to put my 2, and then it's going to be an x to the 6th minus 125. There we go. This is better. So each of these terms can be expressed as something to the third power. All right. So the first one here, all right, x to the 6th, this is equal to x squared raised to the third power. All right. So if I take x squared and I think of that as that thing to the third power, all right, now I have something to the third power. And when you have a power to another power, you multiply the exponents. So that's how I'm working it backwards from that. Or if you do x squared times x squared times x squared, you add up those exponents, and that makes 6 of them total, right? Basically what I did was I just divided the 6 by 3. And that kind of determined my 2 there. And then 125, you might know that, you might not, but that is equal to 5 to the third power. All right. So what I'm doing here is I'm basically taking the cube root. I'm taking the cube root of both of these pieces. So on your calculator, if you have one, math, and then down here, number 4, that's the cube root of 125. And that gives me a 5 there. Awesome. So you were looking for some number so that when you multiply it by itself, something, so that when you multiply it by itself, you get 125. Or for this one, it was you multiply x squared times itself 3 times, and that gave me x to the 6th. That's what we're trying to find. All right, now I can use the formula. So x squared is going to be like my a term, and then this will be my b term again, of course. All right, so it's going to be a minus b. So it's going to be x squared minus 5, a minus b. And then in parentheses, we've got a to the second power. So I'm going to be doing x squared times itself. X squared times x squared is going to give me x to the fourth. And then plus a times b. So it's going to be a 5 times x squared. So 5 times x squared. And then the last one is b squared. So 5 times 5. That's 25. All right, and that's good for that. We got it factored. Yay. Of course, if you wanted to check your answer for these, you could just pick some number for x. Like, it doesn't have to be anything special. Like, you can do 10 stored to x, and then see what the original gives you. Oh, my bad. 2x. Oh, I forgot my 2 right there, didn't I? Yeah, there's a 2 that's supposed to be there on the outside. 2x to the 6th minus 250. So the original gives me this giant number. So that means down here in the factored form, if I typed all that in, it's also going to give me the exact same value. All right, it will, trust me.